Still not tricky enough for you? Okay. Well, let's do a rotation this time where we're going to use two functions. We're going to use the square root of x, and we're going to use the line z is equal to 1/2 of x. So we've got two functions here. Actually, I shouldn't use, I don't like this. Y is equal to this because it's still on the y-axis. And here's our x-axis. And we're still going to rotate around the x-axis. We're going to keep that simple. But this time what we're going to do is we're going to say we rotate both of these functions. And what's going to happen is we're going to define the area in cross-section. This is going to be, this area here is going to be solid, but this area is going to be empty. So it's like making a cup, okay, with a V-shaped hollow void in the middle of it. Okay, so how do we do that? Well, we need to modify our equation. Initially, we had an equation where we were just looking at, derivative of pi r squared dx. But now, that worked when there was just a radius and the object was solid. But now, this isn't going to work. And we're going to use a more general form, if you will. It's pi, and then we're going to have the outer radius of our volume squared minus the inner radius. We're going to use capital R for the outer radius, little r for the inner radius, squared dx. And this is what we're going to use to come up with this new situation. Well, okay, outer radius minus inner radius. Got to square them. Okay, that's clear. What are our outer and inner radii? Well, the first thing you're going to have to do, of course, as it always is, you got to make a great drawing. Because without a good drawing, you're dead. And if he includes a drawing, you can go right from his drawing. But sometimes he just gives you instructions, and it's not immediately clear what the boundaries are. So let me fill in some stuff here. I'm going to say, given these equations, the endpoint for our volume, it makes sense to make it at this point where these lines cross. Okay? If we're up here, I don't know what this is going to mean. So right here, this is at 4 and 2. Okay? Because when we plug in 4 for x, we get y is equal to square root of 4, which is 2, and y is equal to 1/2 of 4, which is also 2. That's where these lines cross. Okay, so that's going to be our limit. We're going to go to 4. Now, let's just draw a little line here. And where we hit the outside of our volume of revolution, that's the outer boundary. We're revolving around the x-axis. We draw this in. That's our outer boundary. What's that going to be? Well, that's going to be the square root of x. So we're going to get here square root of x squared. Okay, minus. Now we start from the center of the thing and go up until we hit the inside of the vessel, the shape that we're creating, the volume we're creating, and that is this function, 1/2 x squared. Okay, so we put 1/2 x. Did I say 1/2 x squared? I just meant 1/2 x. And then this is going to be squared like that. Okay. Pi, and I said I was going to go from 0 to 2 dx. We solve this, and we get the volume of this. The main point here is not solving this rather simple problem. It's making a careful drawing and figuring out your outer radius and your inner radius. Now, what if I had said just at the last second, oh no, we're not revolving around the x-axis. We're going to revolve from 0 to 2 on the y-axis. Oh. Well, we're going to have to rewrite our equations. Okay, because now we're in terms of dy, because the thicknesses of our disk are going to be in this direction. And, you know, this is where those, it's kind of nice to keep track of this. So we have to rewrite this, and we're going to get x is equal to 2y. And here we've solved this before, x is equal to y squared. But now, let me pick a different pen color here. What would be nice? Purple, maybe. Let's look at our inside and outside radius. Okay, well, we start from the center of the thing. We're in the void. We start moving in this direction. We hit the outside of the vessel, of the volume. Oh, we're now on this function. That's our outside diameter, outside radius, rather. And then when we do on to the inside, we start from the middle and we hit this one. That's the inside. So, okay, so that's this equation. So when we set this up, we use it, we kind of reverse the position of those two functions.